didn't see. There we go. So I didn't see anybody have any. Does anybody have anything specific to talk about? I didn't see anything in the email.
I don't have anything specific, but last meeting I brought up whether there's any discussion about AI. Actually, there's an AI co-design working group, and in there, one of the gentlemen brought up uh, the AI, I mean edge AI in that group. So, but John actually mentioned this group as well, so I'm not sure where that topic will be discussed.
Yeah, that's a good question. So, it wasn't here as far as I understand. What we're kind of trying to figure out is what to do with the Edge group and with the Telco group. And what's been kind of kicking around is perhaps collapsing and combining them. So instead of having a separate Edge group and a Telco group, we roll all this together um, to kind of maybe get more of a focus rather than kind of have this distributed this way with kind of the Edge sub working group and then the Telco group having those calls the week before. Does anybody here have any preference, any thoughts, any concerns to kind of combine this kind of telco and edge and bring them back to maybe one meeting? I guess
I
maybe
have a
that's the
question.
first.
I have a
Yep.
question.
Yep.
When you talk about edge, which edges? There are so many edges. There is telco edge, enterprise edge, far edge, near edge. What
Yeah,
edge?
that's a really good question. So this edge group is has it kind of forked out of the telco group. And it originally was very specific to a group of people that wanted to drive things in a very specific way for a telco edge. Over time, we've attracted a lot more people in just a general edge perspective. So we've been kind of bouncing around saying, with the people that are attending and joining us and because this is driven by you all, right? Like, I'm not dictating where we go. It's where does this community want to go? A lot of the community that this was attracting wasn't necessarily tied to specifically telco. Um, it was really kind of driven more around this ruggedized environments and high availability and some of the things that you'd have from a telco perspective, but then also kind of in a distributed remote edge kind of way, which is
So
kind of
what is
yeah.
what is a distributed remote edge? What is it? How we define it?
Well, this is up to us, right? So we're, this group, we've kind of come out of the telco edge, but the people that are joining this community are from outside of that specific vertical, right? And so I keep kind of reaching out, trying to understand, where does everyone collectively, where should we drive this? And do we even need the standard telco? Does this need to go somewhere else? Do should we subsume telco
So,
because a lot of the
Hachim,
same people?
what is your interest in edge? So for instance, what John's referring to is there's a specific piece of hardware called the Open Edge server that this group was formed, 5 years ago to create, and that piece of equipment has been created, and the standards for that or the specifications for that chassis and the sleds have been uh pretty much fixed at this point, right? So there's like 7 people who make those pieces of equipment and they follow the OCP model, and you can purchase those. They're available on the marketplace, all of that. And so that open edge server was a piece of equipment that was typically installed in the base of a cell phone tower to do what's called cloud radio access network. Uh, and as cloud as Cloud RAN has become now 5G and people are deploying it, the edge has taken on a larger meaning. A lot more people are interested in doing things on the edge. So in the open edge server, we were attracting people, say, from transportation groups, either people who wanted to deploy servers on the side of the highway for autonomous vehicles, people who wanted to deploy servers on the side of railroad tracks for railroad traffic monitoring. We had people who wanted to put these on ships. So there was some transportation things. Then there was also a group of people who were interested in putting these into retail edge space. So at uh, the store fronts in the cities, not in the distribution locations and the warehouses, but that where the point of sale equipment and the inventory management for the edge location being a storefront, right? So we had those kinds of interests. And so at the same time, we've had the telco folks, so these are your large communication service providers, have now taken their open edge server, deployed it at what we would call the far edge in telco speak, which would be at the cell phone tower. They're now deploying these at the regional edge, which would be the aggregation point where all of those cell phone towers come together and in a region. And so those servers were now deployed there. Those guys have kind of stepped away from the server aspects, and we've got now a distributed router system that's actually worked on in the telco group, not in the edge, because it's a more centralized telco application server, even though it's a disaggregated router. Okay. Um, and so the folks then who are still in the edge, we continue to have people coming and wanting to discuss what to do about different aspects of the edge. And so now we're saying we're making the OCP and this sub project is saying, hey, we've really got a lot of interest in the edge, people who are interested in the edge. And we think that it's now not actually just about cell phone towers, but it's about a lot of other, could be potentially other things. We've even now had some talk about satellites and putting servers on satellites. So we've moved, from a cell phone tower to a satellite as being the edge. Uh, we don't really have a definition of the edge. We've had some presentations and people have talked about taking other edge taxonomies such as the Linux Foundation's taxonomy for edge, and we've kind of talked about that and how does that fit with the OCP. The OCP doesn't really have necessarily an edge group. And what we've realized is that the servers and the server group has a interest in producing and specifying the hardware. So we've now gone and said, well, you know what? We need to find out who's interested in edge. What is it that they want to work on? We believe that it's around some kind of definition and requirements of what's required for Edge, as opposed to what we did before, which was develop specifications for a piece of hardware. So what John's saying is that we're going to change the focus of the group, and we're now soliciting input from everyone on what does OCP need in terms of edge, and would be very interested in what you have to say about how your interest in edge and what you're willing to contribute to in terms of specifications, whether it's requirement, white paper, that kind of thing about edge and what we need to continue to work on.
Yeah,
Does that,
absolutely. Good,
does that
good,
help
good summary.
some?
Yeah, to give you an example. So, I started with the telecom use case Craig was talking about, but now for me, a lot of my interest is more around industrial edge, meaning, you take compute that moves out into an industrial environment. So it has a lot of the same characteristics. It needs to be, very dense, high capacity, but then also hardened from an environmental perspective. Um, but what we see is a lot of the requirements and things that we drive out of the edge get fed back into the data center and they benefit from it, right? So, can a data center benefit from liquid cooling in a more condensed uh, modular platform? Absolutely. But do they have an immediate requirement for that? No. But as we maybe drive these things from the edge, that can actually feed back into the larger data center community, because those of us trying to deploy these applications on the edge, have these additional requirements of like cool, concerns about cooling and power and environmental vibration, these types of things that normally came out of the telecom world. But as compute moves into kind of this distributed edge world, we see that there's kind of a value to drive this from somewhere that could then also feed into this larger OCP community of what they're doing in the data center, and vice versa, right? So there's work that's going on in the larger OCP community around, say modular CPUs on a motherboard within a chassis and these kinds of things. So the value can move both ways. We can bring in people from the larger OCP community who are looking at what's happening in the data center, and how can we use that technology in the edge, and then we have additional requirements on the edge that could then potentially move into the larger OCP community that serves kind of more of the data center space. And so what Kurt's kind of saying is we're trying to understand where it's not Craig or I or anybody specifically dictating what this should be. It's all of you in the community, and where do you guys want to take this group, and be able to kind of if people can contribute different white papers or what have you, we can start to kind of maybe retarget away from what this group has traditionally been, which had been this open edge server, into a larger value to the OCP community, and to all of us participating here.
Yeah, actually, on the same line, actually, on the AI collaboration, if you have attend those meetings, there's a discussion with collaborating with ML Commons. In the ML Commons, there's a group that dedicated to the so-called tiny ML benchmark. That's exactly what John is talking about, like how to measure the energy use and all that stuff. So that's how they benchmark, but how to define the physical, the hardware specs to meet that requirement could be discussed here. Now coming back to the industrial IoT, does industrial IoT fall into the telecom working groups charter?
It's okay. So the kind of the same requirements exist, right? So if you look at the charter we have, it's very open ended. So the question is do we collapse telco under edge, right? Because telco is just a specific use case of edge in the scenario that was originally existing. Um, and we're what you're talking about with AI, that's very relevant to industrial edge and telco edge because they're all looking at how can I move these very large language models out to these edge points, but I have constraints. I have CPU constraints, I have GPU constraints, I have power, I have cooling. um what's interesting is AI seems to be the catalyst for a lot of rethinking because what Craig was talking about when this original open edge server was put together, AI wasn't really a concern. So a lot of the requirements and things that drove the hardware specifications were about, okay, I can minimize the cooling, I can minimize the power, I can minimize the real estate. But now when you say I got to plug a GPU in, that flips that equation on its head, right? All of a sudden, now you've got this thing that needs lots of power, lots of cooling, and it could be interesting from a distributed perspective. Um, because there's two sides of the coin here. There's this technical aspect, but then there's a cost aspect and a business case aspect. So like there's people that are interested in moving GPU and AI out to the edge, but the problem is it's very expensive. And then how else can I leverage that capacity for perhaps drive other workloads or these kinds of things that can help um, cost justify putting those kinds of resources out on the edge. And then so it changes the equation of what was originally this group was kind of designed for. Was originally it was like, how can I minimize the CPU, or how can I minimize the power, how can I minimize the thermal demands and cooling. But the minute you start saying I want to drop a GPU in here, and like you would do this from the telco perspective because maybe you want to use a GPU to say optimize the air interface, or you want to use a large language model to help optimize the way that your radio is designed. Same things for industrial use cases as well. But there are times then when perhaps that GPU is sitting unused that could be used for other things. There seems to be like this could be a whole new thought process around how to build a distributed data center to help kind of cost justify building these kind of compute out at and this would be kind of the far edge. But like as Craig said, you have this kind of mid-tier edge as well. But that's kind of where in my view we could kind of take this group. But again, it depends on what all of you where all of you want to kind of drive this in terms of contributions and defining OCP specifications and that kind of thing. You guys have any thoughts?
Yeah, just to be perfectly clear, we have the telco project group's charter and the Open Edge subprojects charter have been expanded to include pretty much any idea that anyone has on edge that's not being addressed in another area of OCP. Um, the telco the telco charter in particular, I believe, specifically talks about IoT. Um, and it speaks about things of low latency, access layer hardware, you know, basically anything that's not deployed in a data center. So, central office is not considered a data center. If something's deployed in a data center, then that's covered by standard OCP specifications. And these edge hardwares are also currently covered in the server group in the modular data center hardware. So we believe that the motherboards and those things that are necessary for edge hardware is being produced and has specifications in OCP that allow that hardware to be produced. The question is more, how do you want to apply that hardware? And then is there any additional um, requirements as far as hardware that the OCP needs to specify that would enable the deployment of that equipment, OCP equipment, not telco, not edge, project equipment, but OCP equipment into an edge application scenario. So is it in the telco use case, for instance, what was found was that the hardware that the OCP specified, the open rack, the servers, the sleds, the chassis, the power supplies, weren't adequate for what telcos were requesting. So telcos requested negative 48-volt DC power. At the time, everything in OCP was 12-volt. We've now moved to a 48-volt rail in Open Rack, but that Open Rack V3 48 volts is positive, not negative. So Telco wanted neg 48 power. They've been using neg 48 power for years. They have large installed power plants that are based around negative 48 power. So they wanted a rack system that could be pre-built just like the OCP systems were being pre-built for the data center that could then go into a telecom central office environment. And so the telco group specified a neg 48 power supply for OpenRack V2 because uh, there was not one from the OpenRack project group, and they didn't want to work on one for the telco group people or the participants in the telco group. Likewise, there was not seismic rating for the racks. And so we in the telco group came up with specifications on how to modify the OpenRack V2 in order for it to have seismic protection. So similarly here in Open Edge or not Open Edge in Edge, whether it's IoT, whether it's retail edge, whether it's transportation edge, we're not really we're more talking we're talking these like verticals, I guess you would say, of edge applications because then what is it that's not being addressed in the rest of OCP that would be required for the OCP equipment to be deployed in the edge? And what typically folks want to focus on and talk about are again these ruggedization and environmental concerns. They go, oh, we don't have enough power available on the edge. Our heating and cooling is constrained. We can't install large chillers. We can't put immersion coolers on immersion racks on the edge. We could perhaps use cold plate, but we don't have the ability to put in large chiller infrastructures. Those things are much more suited for a data center than the edge. And what we
Yeah.
need to do is to say, okay, these are the items necessary for deploying OCP equipments into the edge and how we propose to address that. And if we could then have, you know, uh, people who are willing to build the things necessary that the folks who want to consume OCP gear on the edge, but they're not able to because they don't have the necessary environmental, you know, I'm not exactly sure what they're not going to have that they need to to use. I understand that fairly well from a telco standpoint when we're talking about placing hardware servers at the base of a tower in order to do a 5G application on that edge. And I understand what the aggregation edge looks like and what are the requirements there in terms of space and power, cooling, the environmentals, the even the regulations. So, like the NEBs and there are certain, you know, they're not they're not legal requirements. They in the past they have been, but they've been relaxed. But the telcos are required to follow certain specifications. They need certain power ranges. They need certain temperature ranges, for instance.
Yeah. Yeah. To kind of add on to what Craig is saying, so the interest of mine is, if you look at a lot of this industrial IT, they're still operating on technologies from the 70s and 80s because there's this big concern of hardening and robustness and this kind of thing, right? So it's kind of the same situation in the telecom world, but the telecom world has started to open up and start to embrace open systems and open hardware. And just my perspective is there's a huge untapped opportunity in this whole world of programmable logic controllers and SCADA systems and MES systems that right now today are built on a lot of proprietary technology. It's hardened because there is not kind of a standardized open technology that we could play in to start to bring in the proper technology that you need to have AI in. What could you do with AI that's running on your assembly line, or AI running closer to these environments. There's a lot of innovation that's happened and cost reduction that you can bring a whole lot more power into these other spaces now that are closed because they need a hardened type of technology from PLCs, from SCADA systems, these kinds of things. And that's just kind of my thought is to how we could kind of take where the telco vertical's gone and broaden it out into a whole other region of say auto manufacturing or say gourmet food or beverage production, or other places where people are not able to capitalize on commodity hardware and are kind of constricted by these legacy systems out of the 70s and 80s that are still driving a lot of that technology, if that makes sense.
I mean, yeah, I would really be interested in, for instance, the challenges. So, uh, the challenges of organizations that are attempting to deploy an AI infrastructure into a edge environment, like a retail edge, for instance, like a storefront, a
Yep.
a larger department store, but they don't have a data center in that store. They have an equipment closet that typically would have housed wireless routers, uh, network access for their point of sale, their security, and now they want to install an AI system that's going to take that security feed, add some value to it, and not just put raw video footage onto some storage media, but they actually
Yep.
want to take some actionable intelligence from that. They want to have real-time inventory control using AI, and they're not able to use that equipment in that constrained environment because, you know, even air-cooled AI gear still requires a fairly robust operational environment, and they don't have the ability to put in coolers. So
Yeah.
maybe you need a small heat pump that's capable of connecting to a typical air conditioning handling system for a large grocery store or a large department store, even say a big box store, Home Depot, Lowe's, those kinds of things, right? They have a constrained environment, but they want to be able to take advantage of AI on the edge. They want to push those applications down to that edge environment. Those are the kinds
Yeah,
of that we're really needing to come up with. John mentioned
Craig,
manufacturing factory floors. Factory floors are sometimes one of the most harsh environments. They require, a lot of shielding, those kinds of things from heavy electrical, devices, furnaces,
radiation.
presses. There's all kinds of environmental concerns there that will not allow the deployment of AI gear as it's either in its air cooled incarnation today or in more the liquid cooled environment that's required in order to run this equipment.
Yeah, I mean, I can tell you guys. So right now, I run a large GPU cluster in a data center, and it is so noisy. It is so loud. You can't sit there, and you can't even be in the same room. And it's air cooled. And in a previous lifetime, I worked with a large box retailer, and it was exactly what Craig was saying. It was like they had this data center shoved in the back of the store. It was disregarded. Nobody really maintained it. But I'm just imagining if you tried to drop in 8 GPUs into that space, that this noise level would now become a huge problem. Not only the power part of it and the space, um, because you would definitely hear it out in the store. There's no way you could have this like stuck in the back of a room. Um, so if we all kind of feel that this AI in this retail space and industrial, and telco, these are kind of the areas I think we can address because I don't think people are really talking about this stuff today. They're all thinking this stuff goes into a data center. But going back to my retail experience, there's when you're running an item through that self checkout, you do not have the luxury to send that back to some centralized data center because that slows down the whole checkout process. That's why they have these little data centers in the back of the store that are doing that. But if you want to start to apply AI to it, you're not going to haul that back to a cloud somewhere. It's going to need to be low latency. Um, and that's kind of my thought process of what we could start to look at in terms of driving kind of OCP forward here, kind of on these distributed environments.
So now, for the far edge, have anyone put the VPU or AI inference card or even the GPU in the system to take care of the local AI inference or the processing local, the far edge side?
Has anybody done that? Is that what you're asking?
Yeah, in the far edge chassis inside, have anyone looking for the SPU, the accessory car, in the far edge side into the chassis directly. The mean maybe we can handle some AI inference or video on the far edge side locally.
Yeah.
Yeah,
So
exactly. Yeah, go ahead,
So
Craig.
Roger, in terms of AI cards, we didn't call them AI cards, but we had
Mm-hmm.
several um, iterations of GPUs that were used in
Mm-hmm.
the open edge chassis. So we could
Mm-hmm.
take a 2U full length, full height PCIe system, and I believe it was 600 watts of power, because in cell phone processing there is a um, in the layer one, there's a
Mm-hmm.
LDPC processing that required some kind of offload capability for a CPU to do that work. So when you put
Mm-hmm.
a server into the at the base of a cell phone tower to do the
Mm-hmm.
radio access network, it
Mm-hmm.
requires an accelerator card, and we've used several versions of GPUs. There's a specialized card from Intel as well that's used for that LDPC offload capability. So we have done that for the telco edge, and so
Mm-hmm.
we're somewhat aware of that, and these were in the NEBS temperature range, so uh,
Mm-hmm.
neg 45 to 60 C, right? Uh,
Right.
range. And so we were able to do that. We couldn't do as many, and we've not
Mm-hmm.
looked. So as a telco side, right, and the telco edge, we've not looked at inference systems, the newer uh, the newer systems that have come out, because
Mm-hmm.
like I said, or like we said earlier, those specs for the open edge systems have ceased, right? So we're not continuing
Mm-hmm.
to develop those chassis anymore. But we
Oh.
believe that there will be issues around both, not only the uh, heat rejection necessary from these cards and systems, but also uh, from the power requirements, right? So a
Mm-hmm.
lot of these smaller form factor motherboards that we've been using that are typically a half U don't have the connectors on those boards to enable enough power to,
Mm-hmm.
to drive those cars, right? Because you plug in the PCIe slot, that's really the data interface, not the power interface. You still have to have an external cable to plug from those cards onto, typically the motherboard. Although in some cases we've used a power insertion board to actually get more power than
Mm-hmm.
the motherboard was designed to provide. But yeah, those are totally the issues we're talking about, Rod, for sure.
Yeah,
Yeah,
yeah.
and
We saw the no Nokia have the 3U final or even the 2U 3 now. That is the open edge solution you are talking about that. But that is for the VDU. That's for the DU solution focus. Is that?
That's correct. But
Mm,
we're now moving to other forms and other form factors based on, some of the applications that our customers are looking to deploy,
oh,
right?
so not
But
just only the Martino in 3U or 2U,
yeah,
and
well,
also
so yeah, I think we're also interested in, and this is from, I think some of the this is more of a telco open edge, which we're
mm-hmm,
really we're really thinking that this group needs to transform from telco edge space to these other edges. But in terms
oh,
of the edge requirements for telco, I believe that there's a significant interest now. There's a new group that was formed, the AI. Is it
mm-hmm.
AI RAN, John? I think
yeah,
we're talking about
ARN, yeah.
working on
Oh
that,
yeah,
right?
run.
Yeah, and so
Yeah,
what
we.
they're
Mm,
right, so 6G, so 5G cell phone service has, we're now deploying that. Everyone's rolling it out. There's the the telcos or the service providers
mm-hmm,
seem to hype the next generation before they've actually deployed it, right? But right now we're in
yeah.
there are wide scale deployments going on of 5G, and they're now looking at the development of 6G. So 6G is very
Mm-hmm,
active, and that'll be in 5 7 year time frame before it's really deployed, maybe 10 year time frame. But
yeah.
that LDPC line coding that I was talking about is now being targeted to be used as an AI application so that that
Mm-hmm.
coding can be done in a more efficient fashion and doesn't have to be fixed because we know that certain these are all for forward error correction, right? So
Mm-hmm.
these forward error correction algorithms work better if you're close to the tower, or there's some that work if your signal to noise ratio is lower,
Mm-hmm.
which would be at the fringe areas, right? And so one of the challenges when you're standardizing these layer one um, protocols for use is, do I optimize this for traffic that occurs, closer to the tower or farther from the tower? And then you make a decision, and that's the algorithm that you end up using. And so in 5G, for instance, there's actually two different protocols, a turbo encoding that's being used, and then this
Mm-hmm.
LDPC
Robot
code,
encoding.
depending on whether it's user data or whether it's control plane data.
Mm-hmm.
So the effort in 6G is to actually use AI techniques to be able to predict where that customer is, so where the cell phone handset is located, and then as it moves farther, and so its signal to noise ratio is dropping off,
Mm-hmm.
that you can then adjust the encoding method to better optimize for that handset rather than having to make, this a priori decision on what your encoding is. So you have variable encodings that will occur based on where the handset is in relation to the antenna. So
Yeah.
that is now driving the uh, equipment to use a more uh, GPU based processing in the tower, because then what you want is the handset that people are carrying with them, their cell phone, to be able to use a an inference model that doesn't is not so power hungry, doesn't require as much CPU, or not CPU, but computational effort. But then at the location, the cell phone tower, that's where the computational heavy part would be occurring, right? And further up line, I mean, you can have those feed each other. It's not, like I said, it's 6G, so it's still kind of under discussion as to how this is going to occur, what the protocols are going to be, the algorithms. But there's certainly this need to move the GPUs that we, current generation GPUs, the next generation GPUs that have been announced, uh, to to for that application. Now I'm just talking now just about the telco side, not what they're requiring for the industrial edge and IoT, but I believe
Yeah.
that's going to end up being the exact same
Yeah.
mechanisms
Yeah.
as
Yeah.
we
You know,
use AI.
if you think about the
It will be
industrial world, right?
yes. Go ahead.
Yeah. The industrial world's kind of the same thing, right? So, they're living off of like 80s and 90s technology, but like if you could start to bring in AI into how a programmable logic controller works, today they're extremely simple because they have a very kind of limited architecture. But if you could start to provide the proper compute at that level, you could start to have much more AI brought closer to, how does manufacturing work? If I was looking at some statistics, the average production line is only about 50, maximum 60% efficient
Mm-hmm.
because it is, running on a lot of very, very, very old technology. When we're talking about, things like Craig said, retail, oil and gas production, manufacturing, auto manufacturing, food and beverage, all these kinds of things. They have not been of they have not been able to take advantage of a lot of the innovation that's happened.
Mm-hmm.
And then, if you want to bring AI into it, it's going to be in these much more hardened environments, right? And you can't have the latency of going back
Mhm.
to a cloud, you're going to have to move this closer. You're going to
Yeah.
have it nearly on board. And it's just really surprising to me that like I don't see any of the major OT vendors driving a lot of hardware that's like cutting edge and these kinds of things. There's still proprietary processors and like antiquated programming languages, these kinds of things.
Yeah, that is the reason why the sometime the Nvidia have pushed the AI RAN. But but until now, we believe that even in the 5G, no one make money back on the 5G. But now industry looking forward for the 6G. That may another the 10 to 15 years. The the need to working together.
Yeah, I just I've been looking at this OT industry and like they seem to be completely, they're paralleling the telecom industry, but they're behind. So like you
Mhm,
could take a lot of the parallels of where the telecom industry's gone. And it was funny because I said, we were having this discussion. I said, if you think about a class 5 switch, it's just a
mhm,
bunch of giant relays, which is
mhm,
exactly what, a lot of this OT stuff is. And, if you could start to bring in much more modern technology into those
mhm,
spaces,
mhm,
there just seems to be a lot there that nobody is really addressing. And there's like these embedded vendors, just like in the telecom world, that could be a ripe avenue to say, hey, let's get some open hardware technology in there and some open
mhm,
software stuff in there, and we can help really revolutionize
mhm.
these things that like have been really hard to penetrate. And when you talk to
Yeah.
those people, they're like, oh no, we're so different. We need to be secure. And it's like, you know what? That was the
Mhm,
same argument the telco folks had.
mhm,
And so I'm just really surprised that like nobody's doing this, but like I would really like to see OCP, us be able to start to kind of drive into kind of some of these avenues that have been kind of closed to this, just like kind of telco has been kind of opened up.
How about looking for the ARM processor? Are you looking for that? That's some the performance per watt benefit compared with the x86. That made another good advance when that looking for the system in the far edge.
Yeah, if you look at a lot of these programmable logic controllers and SCADA systems, it's all still closed proprietary hardware. So like, you know,
Oh.
X, like yeah, like it's very closed from a specific
Hmm.
set of vendors,
Okay.
and just like we've been able to kind of open up the telco vertical.
Uh-huh. Uh-huh.
There's all of this OT, operational technology, programmable logic controllers, SCADA
Mm-hmm.
systems, and
Mm-hmm.
even that whole if you look at their architecture, it harkens back to the 60s and 70s, and it's all designed around the fact that you have limited compute at the bottom and you've got to
Mm-hmm.
bubble up all this data to the top. And it's like, well, no, what if you had the compute power to put that at the bottom? Because now we've changed the economics to say you can have this kind of crazy compute at the bottom, at the edge, but
Mm-hmm.
their architecture is still so kind of closed because it was designed from the 60s and 70s that you had very very limited compute at the programmable logic controller and the SCADA system. And then there's like a 5-step hierarchy of PLC, SCADA, MES, ERP, and they're very locked into this architecture that's very very
Mm-hmm.
rigid. and
Yeah.
and and it's all because of the technology that existed in the 60s and 70s. And
Mm-hmm.
so my thought is what we could do now today, and if we could do this through the OCP and really kind of open this up,
Mm-hmm.
there's just a huge opportunity there to really, bring AI all the way down into, why isn't AI kind of into these spaces?
Yeah. Yeah. Are you guys also plan to join the MWC in this year in Barcelona?
The Mobile World Congress.
Yes.
I don't have plans to go. Craig, do you?
I'm sorry. I will not be attending Mobile World Congress, but Nokia will have a large presence there, I'm sure.
Mm-hmm. Oh, actually, I handle the ARM product line in Supermicro. We do have the one system is official design into the NTT Docomo, and we have some system demo in during the Mobile Congress. Yeah, and that's the ARM version. And why we using the ARM version? Because that it's similar with the Open RAN, a separate for the different the AI for the RU DU CU separate. But now we focus on the DU side and also implement has a ARM solution accessory that they are using the Nimbus N1 and also the server system also using the Nimbus N1. That's by the ARM core, and so we do that as to saving the some power and also the higher the core count to can be handled the layer two, the software. So that's some the benefit we are working on with the Docomo team. And but others, Docomo also have a demo. Others, a lot of system that they all from Intel. Yes, just only one for the ARM version.
Interesting.
Yeah, that is something we are working on now. But we are very interested to if we can have others AI workload can implement with the system together. That may have a more benefit, not just only working for video only. So that is something we are interested in.
Yep.
Well, we would be interested in having, say, a joint Docomo Supermicro white paper or a detailing how this would work with OCP equipment.
Mm-hmm. Yeah, but that system, our system not put in the supermicro booth because there is not is the some the specific project. So we have a system in the Docomo booth, in the ARM booth, and our in Fujitsu booth only. So if you are interested in that, maybe we can meet
Well,
to
the
build the
OCP is
system together.
very interested in AI. It's one of our strategic initiatives for the year, and we would welcome any submissions and like I said, of white papers, those kinds of things, including
Mm-hmm.
deployment specifications. All of those things are helpful for the OCP community.
Yeah.
Yeah.
Understood. So that actually that is the the system we are showed it up in the Docomo booth.
Mm-hmm.
So there's a eight system, oh sorry, seven system from Dell and two system from HPE and one system is from Supermicro. There's only one the ARM version in the Docomo solution.
And so, are any of those OCP based systems?
No, that will be the standard uh, uh, edge server.
So, why
What's
would those
the
servers? Why would we, as OCP, right? How do we
mm,
incorporate this into the OCP open hardware charter? So I'm looking for directions from you guys because you're the ones who are participating members on behalf. Docomo is not an OCP member,
Not
but I know
not yet.
Supermicro is and
Yeah.
produces
Supermarket is, yeah.
documentation.
Yeah, but the supermarket also have a 2U3 node, the similar with the Nokia version. But in the case, they are choice Docomo chose the ARM version because the ARM version
But
can
but
easily
Roger,
lower the
I'm not
high.
Nokia. I'm not Nokia here. I'm OCP,
Oh,
Open
okay,
Project. Okay. I'm
okay.
just trying, I don't care what Nokia does necessarily, especially
Uh-huh.
working group, right? This is an
Yeah.
open compute working group, and we're trying to get content for the open compute community,
Hmm.
right? I understand what's
Yeah.
going on in the industry, don't get me wrong, right?
Yeah. So now, other than the technical, we are interested about the compute age, computing in the age. So we try to
Yes,
uh,
yeah,
try to support more the accessory car, not just only the DU car.
yeah.
And so we're looking for the AI. So previously we working with the partner. For example, the try to put the accessory car, for example, the Qualcomm car or VPU or something like that into the edge. And because some the deal side requirement is just only one or two, the inline DU is good enough. So we still have a lot of space to support a different accessory car. For example, the NPU, IPU, VPU, something like that. So that's something we are working on. But that try to figure out have any the killer solution we can do. For example, the DU that do the LDPC in the far side close the tower. But if we can also do the video on demand or do the inference model, large inference model in the far side, that made a different application opportunity.
Hmm.
Yes, so that is something we are trying to study and get some the customer feedback. And in top of that, there's some the BU focus, but the button that will be the different. For example, the retail put the application that the VPU should be good enough, or do the CDN. Yeah, that's something the different the accessory car, but focus on the different solution.
Yeah, and see that, Roger, this is what I was talking about when I said for 5G deployment that's being deployed
Mm-hmm.
currently, right?
Yeah.
And so what we're trying to accomplish is to say, okay, what's necessary, and I mentioned 6G, which is
Mm.
still under deployment,
Oh,
right? It's kind of
6G.
like we understand what people are buying today. The question is, what do we
Yeah.
provide specifications for the future? And
Uh-huh.
especially though, in particular for the Edge group, we're interested in not just telco. We're being
Yes.
asked to do a lot of verticals, the
Mm-hmm.
Yep.
manufacturing, transportation, you know,
Yeah.
how are the retail, how are those going to need what's necessary to enable this equipment to be deployed for their applications? That's what we're really searching for in
Uh,
in the group, and what we're actually, kind of readjusting the focus of this
mm-hmm.
work group, because we're the open edge is the template for these servers that you're talking about, and
Yes.
the
Mm-hmm.
accelerator cards that you're talking about are what I was talking about originally that we had designed the equipment for. And so
Mm-hmm.
now you guys are making a piece of equipment that's basically an OCP uh, inspired piece of
Mm-hmm.
hardware, right? but you didn't provide that back to the OCP as an inspired specification. So as a result, we have a group that has hardware that's being sold by several people, several different
Mhm.
manufacturers, that's not saying, hey, this is an OCP inspired product. And so all of you guys that were in telco in 5 years ago who wanted to have an open source hardware specification, they don't have that now,
Mm-hmm.
right? And
Yeah.
so from an OCP standpoint, from an industry standpoint, I don't really care. I like that my 5G works and the protocols and all of that we've built and deployed. And I'm happy to see wide scale deployment of that. Nothing makes me happier, right? Because I've been, waiting 10 years for this.
Yeah.
Right?
Yes. Mm.
So, yeah. Anyway, so what we're trying to address now though is, I don't know, on the Super Bowl, for instance, right?
Mm-hmm.
SpaceX and T-Mobile were announcing their
Mm-hmm.
radio in the sky. There's the AST Space Mobile that's deploying satellite, right? So that's what I'm saying. There's new technology, there's new frontiers that we believe can be addressed by open specifications, even to the point that, you know, they just need to be described as an open spec. Like what is it
Yeah.
that's similar about all of those equipments that you're saying are going to be displayed, say at Mobile World Congress? What's similar about those? Do they all have neg 48 DC inputs? Do they care about that? Right?
Mm-hmm.
What is it? What is it? Do they want air cooled machines? Do they want a certain form factor? How is that described? Right?
Mm-hmm.
Yeah,
Because
and how do we move all this forward, right? So Open Edge was a stake in the ground, but like now we got to move this forward. There's new use cases, so smaller form factors, tighter tolerances, more robust environments. You know, we got to move beyond where we are and like what's the next step, right? And what new markets can we go after, right? Telecom's
Mm-hmm.
great, but there's all these other things that have not even
Mm-hmm.
been discussed, and they're going to be more tight, more constrictive in terms of space and power and cooling, and that's kind of where we want to see where you guys want to take this, right? And what's the next spec that we need to start driving? How do we take this into other verticals, retail, industrial, what have you, right?
Mm-hmm. Yes.
Okay, guys. Well, I think we're kind of over our time limit. I appreciate all your input. This has been really good discussion, and look forward to talking with you all next month.
Mm-hmm. Thank you.
thank you,
All
John.
right, all right. With that, we'll cut it off. Talk to you all later.
Okay. Bye.
Bye.
Bye bye.